Jai Hind. Today I am here to discuss very important topic of computer network that belong to the unit 3. The topic is congestion control at the network layer. Myself, Dr. Santosh Kumar Upadhyay, Associate Professor, Department of CSC, Akgec, Ghaziabad. So, as we know that congestion, what is the congestion? Basically, congestion means there is a network traffic in the computer network, and when the packets of network from different sources are not delivered to the destination due to the jamming of the signal or jamming of the packet. That means there is not available enough bandwidth so that can be delivered to the destination. So that means there is a congestion. That means different packets are colliding to each other, maybe, and the information is lost, packet is lost. So how we can ensure that the congestion in the network can be, controlled? So at the network layer, we know that in computer network there is the number of layer, different layer, like there are the 7 layer. If we talk about the OSI layer, then network, application, then data link, presentation, then data link, then transport, okay, a network, physical layer. The number of layers are there. And when we deal the congestion, then we have some different policy. When we are dealing at the network layer, we have a different policy when we are dealing with the transport layer. So here we are discussing about the network layer. Okay. So congestion control refer to the technique used to control or prevent the congestion. Congestion control technique can be broadly classified at network layer in 2 categories. One is the open loop and other is the closed loop congestion. Open loop congestion and closed loop congestion. Okay. So when we are talking about the open loop, there are the number of strategy like retransmission policy, window policy, acknowledgement policy, then discarding policy, admission policies. Similarly, when we come to closed loop, there are a number of methods that can be used like back pressure, choke packet, implicit signaling, explicit signaling. All these are the techniques or policies or strategy that can be used at the network layer. Okay. So basically, the congestion control policy can be divided into 2 major parts. First is the open loop and other is the closed loop. Okay. And then open loop have the number of strategy or policy. Closed loop have the number of strategy. What does it mean, open loop? Open loop congestion control policies are applied to prevent congestion before it happens. Open loop means we are applying the strategy or the policies or the mechanism so that the congestion can be avoided. Means we want to prevent the congestion by using the open loop. This is the open loop. Open loop means we are trying to prevent the congestion. So we have to apply the strategy before it happens. The congestion control is handled either by the sources or by the destination. So both can handle, both can initiate the policy. So policies adopted, and what about the, what about the closed loop? So closed loop congestion control technique are used to treat or elevate the congestion after it happened. So this is the basic difference. Okay. In open loop, congestion prevention, we are talking about the congestion prevention, so that congestion can be avoided. Another is the closed loop. In closed loop, we are applying the strategy after congestion, after congestion taken place. Okay. So we are applying the congestion control strategy after it happened in closed loop. Open loop means we are applying before congestion. This is the basic difference. Open loop before congestion, and closed loop after congestion we are doing something, so that the congestion effect can be avoided, can be reduced. So let me come at the first one, that is the policies regarding the open loop. So first policy is the retransmission policies. So whenever there is a congestion, it is the policy in which retransmission of the packet are taken care of. If the sender feel that the sent packet is lost or corrupted, the packet need to be retransmitted. This transmission may increase the congestion in the network. As we know that whenever a packet is lost or packet is dropped, then to retain that information, the information, or you can say that packet is retransmitted to regain the information, to retain the information. So to prevent the congestion, retransmission timer must be designed to prevent congestion and also able to optimize the efficiency. So in this retransmission policies, retransmission timer should be there. Okay, retransmission timer should be there. That means when to retransmit. So when a packet is lost and acknowledgement is not received, so sender immediately cannot send the retransmit the packet. Okay, so that the frequent retransmission can be avoided by designing the retransmission timer. So what happens in retransmission timer? That means whenever a sender send a packet, then that sender have to wait up to the time when the timer expires. Okay, that means this is the time duration in which the acknowledgement may occur. Okay, it may be possible that acknowledgement packet is, that is not get the proper or free space or free path to come toward the source. That it may be delayed. Okay, so unnecessary we do not, sender do not transmit the packet immediately. That have to wait, and certainly when the timer expires, then they have to retransmit. So this is the process when to reduce the number of frequent retransmission. Okay, because retransmission may create the overloading or may create the congestion. So this is the retransmission policy. That means immediately cannot retransmit. There is a timer. When timer expires, then you can retransmit. Okay, so this frequency can be reduced by using this. Other is the window policies. What is the window policy? The type of window at the sender side may also affect the congestion. Okay, so there is a window policy. Several packets in the go back N window are resent, although some packet may be received successfully at the receiver side. So this duplication may increase the congestion. Like in the case of, remember the go back N. There is a method for go back N, sliding window protocol, go back N, stop and wait, selective repeat. Remember. So here, what happened in go back N? Whenever a packet is not received, acknowledged, then we have to go back N. That means we have to go back at that particular packet, and all the packets succeeding that packet number, that packet, are retransmitted. Okay, irrespective of it is delivered to the receiver or not. It may be possible that packet 1, 2, 3, 4, 5 by the sender are sent, and packet 2 is means destroy or lost, but packet 3, 4, 5 are delivered. But in the case of go back N, we have to go again. Sender will go to the packet 2, packet number 2, and retransmit all the succeeding packet 2, 3, 4, 5. So that should not be the case actually. that should be avoided, because this create or generate the congestion in the network. So therefore, selective repeat, there is a process of selective repeat. What is selective repeat? That means in this case, negative acknowledgement come from the receiver to the sender to indicating that this particular packet number is not received. So what source do at that time? So source go to that particular packet from their window, okay, and only retransmit that particular packet, not all the packet following that packet number, okay. So this is the selective repeat. So this is the window policy. That means there should be window for what? To keeping track of which information or which particular packet is lost, and that particular packet is only be sent, not all the succeeding packets. Discarding policy. There is other policies known as discarding. Discarding means simple, as the name suggests. Discard means just discard the packet, drop the packet. When a good discarding policy adopted by the router is that the router may prevent congestion and the same time partially discard the corrupted or less sensitive packages, and also be able to maintain the quality of the message. In case of audio file, like router can discard less sensitive packets to prevent congestion and also maintain the quality of information or audio file. In the case of audio information, video information, animation, all these things, images, in fact, some partial packet or some packet which is not so sensitive, that is not so critical, may be discarded. For why may be discarded? The router should discard to reduce the traffic. When the traffic is overloaded, router is overloaded, then that should have intelligence to find out the less sensitive packets, least sensitive packet, least critical packet, and that may be dropped. Because in the case of file like video file, audio file, if some particular packet is dropped, it may be possible that that image or video may be some, that quality may be some blurred, or some, edges may be cutted, but it will not be the case that total information will be destroyed or will be lost, okay. So there should be discarding policy on the basis of the input data. Which type of data is there? Certainly, if there is a textual data, then we cannot discard, because discarding may lose the information. But in the case of audio, video, images, we can destroy some packet which are least sensitive, that may be dropped. Why may be dropped? To avoid the congestion, to reduce the congestion. Then other is the acknowledgement policy. Acknowledgement policy, since acknowledgement are also the part of load in the network, we know that whenever a packet is not delivered successfully to the destination, then in that case, that packet may be dropped, may be lost in the network. So that packet, to ensure the robustness of the, to ensure the correctness of the information, that particular packet should be retransmitted. So there should be acknowledgement policy imposed by the receiver, may also affect the congestion. Several approaches can be used to prevent congestion related to the acknowledgement. The receiver should send acknowledgement for n packet rather than sending acknowledgement for a single packet. This is known as the cumulative acknowledgement, cumulative acknowledgement. There is a concept of cumulative acknowledgement. Similarly, negative acknowledgement. Negative acknowledgement. All these are the state G that come under the acknowledgement policy. Cumulative means receiver is not going to acknowledgement each and every packet, because that generate the traffic, unnecessary traffic, and network may be overloaded. So in that case, number of packet is acknowledged in group. Like when the receiver received packet number 1, 2, 3, 4, 5, then that send the acknowledgement. है ना, ACK for the sixth next packet. That means when send the acknowledgement 6, receiver send acknowledgement 6 means what? All the packet preceding the 6 means 1, 2, 3, 4, 5 are received, and receiver is expected packet number 6 from the sender. Okay. So, this is the cumulative acknowledgement. Okay. The group of n packets are acknowledged. Negative acknowledgement means when the number of packets are sent by the sender and receiver got or received the message or received the packet, but there is some particular packet which is dropped, which is lost, which is not received successfully, then there is a provision of negative acknowledgement, NAC. So, this negative acknowledgement is sent by the receiver, so that sender come to know that this particular packet is not received and retransmit that particular only packet, like in the case of selective repeat sliding window protocol. Okay. Or acknowledgement only if it has sent the packet or a timer expire, or the concept of timer. Okay, when timer expire, then only. So, admission policy, the other policy is the admission. Remember that we are discussing here congestion control strategy, techniques or policies at the network layer. Remember, on network layer. So, there are the two policies, open loop and closed loop. We are discussing here open loop policies. Open loop means the strategy that applied before the congestion happened. Okay. So, in admission policy, a mechanism should be used to prevent congestion. Switches in a flow should first check the resource requirement of the network flow before transmitting it further. Okay. Admission policy means when a particular, suppose at a switch or router, a particular traffic or packet is coming. Okay. And that certainly that switch or the router have to forward that toward destination. Okay. So, in this admission policy, that particular router have to, a particular switch have to check that what is the size of that particular packet that need to be forwarded, and what is the available bandwidth of the outward channel. Is it possible to put this particular packet without congestion on that forwarding, that outgoing channel, outgoing path? If it then can be sent. Okay, that means the packet size should be less than the available bandwidth. So, that should be compared, that should be matched first, that should be determined first. This is the admission policy. Okay. If there is a chance of congestion or there is a congestion in the network, router should deny establishing a virtual network connection to prevent further congestion. So, virtual network connection, if there is some request, then that can be denied. Okay. So, all above policies are adopted to prevent congestion before it happens in the network. So, what we have studied here, there are the number of open policy, What is the policy? All these policies, retransmission policy, retransmission, then window policy, then third one, discarding policy, then what is next? Admission policy. So, these are the policies that can be used to avoid or to prevent the congestion. Acknowledgement policies. Next, we come at the closed loop congestion control policies. Okay, that means now we assume that congestion is happened, then what we have to do at that time. So, first one is the back pressure. What is the back pressure? Back pressure basically is a special kind of signal or the packet that can be sent from receiver to the sender. Okay. So back pressure is a technique in which a congested node stop receiving packet from the upstream node. So just prior node from where the packet are coming to a particular node, and suppose that particular node is congested, then that stop the receiving the next packet coming from the upstream. Okay, like this is the receiver and this is the other node, and the packet is coming from this particular node 1 to node 2, and suppose node 2 is congested. That means number of requests are coming to a particular this router. This may be router or any system router. So that router stop the receiving of the packet coming from this node 1, and this is the upstream node, upstream node. This is the upstream node and this is the congested node. So in that case, this may cause the upstream node or nodes to become congested and reject receiving data from the above nodes. Back pressure is a node to node congestion control technique that propagate in the opposite direction of the data flow. Like here, suppose this third node is congested, and suppose third node is receiving the data from this path. Okay, and at a particular time third node feel that become congested node now, that is not able to receive the data further. So what happen in that case? That third node propagate in backward direction a small packet, node to node. Remember, node to node. That means this send a back pressure signal to the second node, then second node in turn send the back pressure node means signal to the first node, and then the particular to the source. The same information is sent. So when this back pressure finally received by the source, then source come to know that node third is not in the position to receive the data, that is congested. So source unnecessarily now does not send any packet to this path to node third. Okay, so this is the case. Back pressure, choke packet technique. The other is the choke packet technique. This is very similar to the first, means back pressure, but there is a difference. This choke packet, when the third node feel congestion, the third node sent a signal packet named as choke packet directly to the source, not to upstream node, then this sent to the next upstream node, means that is not in part node to node. Now this choke packet propagate directly from congestion to source, that may follow any path. Okay, because in previous there is a time delay. Okay, time delay, and this back pressure unnecessary again creates some traffic, and you know that the second node may be get congested due to slowing down of the output data flow. Similarly, the first node may get congested and inform the source to slow down. So this is the case. In this case, choke packet is directly sent, propagate to the source. So time means this is very efficient in comparison of the previous one. So whenever the resource utilized exceeds the threshold value which is set by the administrator, the router directly send the choke packet to the source, giving the feedback to reduce the traffic. Okay, so this is used as feedback to slow down the source. Okay, the intermediate node through which the packet has traveled are not warned about the congestion. All the intermediate node through which that travel that propagate is not warned. But in the previous case, all the intermediate node are also warned to slow down. Third case is the implicit signaling. In implicit signaling, there is no communication between the congested node and source. So this is the other case. In here, congestion node is not going to send any message, any feedback to the source. So what happened here? the source guesses that there is congestion in the network. For example, when sender sends several packets and there is no acknowledgement for a while, one assumption is that there is a congestion. So this is implicit signaling, means implicit intuition. Okay, the knowledge of the source. Source are sending multiple packets and not received a single acknowledgement. Then that itself come to know that there is a chance of congestion in the network. That is the implicit signaling. There is no explicit signaling is required. Fourth is explicit. Explicit means some external signal have to establish. So in explicit signaling, if a node experiences congestion, it can explicitly send a packet to the source or destination, okay, to inform about congestion. The difference between choke packet and explicit signaling, choke packet is also same kind of, that means when the particular node feel congestion, and then at that time that propagate a control signal known as choke packet to the source to slow down, to give the feedback that please slow down your traffic, reduce your traffic. Okay. So, but difference here in this explicit signaling, the difference is that the signal is included in the packet that carry data rather than creating a different packet in the case of choke. Okay. So, next is the forward signaling and backward signaling. The explicit signaling can be of two kinds, forward or backward signaling. So, these are the about particular congestion control policies that can be used at the network layer. Thank you. Thank you very much.